Now I wish to throw some light on the growing stress on Indian power generation because of this flexibilization and RE integration. First of all, I think you might have observed India has successfully met an all-time peak power supply yesterday, that is 19th May at 1540 with 260.45 gigawatts. The previous day on 18th itself, we have met 258.115 gigawatts. So actually government CEA has expected a maximum peak demand of 270 gigawatts during this summer in the month of May or June. But prior to the onset of June, in the May itself, we are going to face the highest peak demand. So this is almost this accelerated growth is on an average 8.9 to 9% every year. Though it is non-linear, we should be ready for this. This is happening because of rising industrialization, HVAC loads, data centers, and intense summer heat waves, ongoing summer heat waves. And one more thing is RE energy utilization. Since everybody is having RE, almost most of the people are having RE solar panels on their rooftop. Since the energy is also of low cost and free sometimes, people are tending to use huge energy. So that's why that is one of the recent factor we have noticed. Because of that, the peak triangle is happening in the demand. So the next, as I have said, demand, we have to get ready to meet 270 gigawatts. Seems to be it is going to 289 also as per one extrapolation. So now if you see how the things are moving among the thermal, solar, hydro, nuclear, gas, wind, storage, all these things, whenever the demand is peaking, the conventional fossil generation is coming down. It is to be flexibilized since the RE green generation is to be used much. So if you see the three happenings among the April peak and peak on 18th and peak on 19th, the solar percentage is high. So this can be explained using a duck curve. This is the duck curve. I think most of you are aware of it. It is like this. When non-linear demand is happening, if you take the demand curve, this is a day demand curve from 0 hours to the 24 hours. The demand, whenever the solar generation is going up, solar generation is a bell-shaped curve, and our demand, fossil fuel generation demand curve is almost a bucket curve or tub curve. So as the solar generation is picking up, grid operators, that is SLDC, has to back down the generation further. So that's how a duck belly is forming as the solar generation is going up. But after sun sets, the solar comes down from the peak to the almost zero around 6:30. From that time onwards, the real stress on the thermal generation starts. That's how the duck neck and head is going up like this. So that is the main stress point on the thermal generation. We have to, manage this. How the flexibilization attains this duck curve non-linear demand pattern, and what we have to do as far as the thermal generation is concerned, let me explain. So because of this flexibilization, as per the instructions of CEA, previously it used to be, as said by Mr. Sanjeev, it is used to be 80 to 90% PLF. But nowadays, we are not able to maintain more than 55 plant load factor, 55 to 60 only. So government has given a mandate to flexibilize the thermal units to 55%, then to the deep flexibilization of 40%. Not only reducing the load to 40% of TML, the ramp rate also should be followed as given by the mandate given by the CEA, 3%, 2%, 1%. 3% from 100 to 75, 75 to 55, 2%, and 1% from 55 to 40. So this ramp rate is the most dangerous as far as the thermal plants are concerned. Let me recollect the incident that happened recently at Chhattisgarh thermal power station of so 45 people have died. At that station, what exactly happened, some fan problem was there. They have taken second oil pump, lube oil pump of the PA fan, and they tried to raise the load as per the instruction of the SLDC. The ramp rate was as per the mandate of the CEA. Since it is most dangerous at that point, because of the accumulation of the coal powder inside the furnace, it has exploded. So these sort of happenings may happen in future. We should not expect such type of dangerous things, but it may happen. So these are the things to be addressed whenever flexibilization is implementing the thermal. So what is the experience of India for these thermal plants flexibilization? During the reducing the load and raising the load because of these frequent changes, we are experiencing fluctuation in steam temperatures, high drum level swings. Drum level, it is unable to control by the operator to maintain the drum level. So high drum level swings are there. Flame disturbance in the furnace is happening. Furnace pressurization is also, many times our units have tripped on furnace pressure variation. So that is happening whenever load is being reduced to 45% or 50% as per the demand of SLDC. Next, one more thing, whenever we coming back to 40 to 45%, the primary air requirement will be less. So at that time, primary air fans may stall, desynchronize. Since the PA fans are running in a synchronized mode at a 900 mm water column pressure, if we reduce the fuel injection into the boiler, these PA fans may deparallelize and may stall, and a unit will be tripped. So that is the one of the important problem thermal plants are facing. And low flue gas exit temperatures, ramp rates are, we are not able to maintain the ramp rate. We are sometimes able to maintain the 55% and 40% in supercritical units, but ramp rate, it is just highly impossible by any thermal power plant. So let us go through the global experience. It is very important to mention here that Germany is successfully converted all its coal lignite fleets to flexibilize up to 20 to 25% of technical minimum load. With 4% ramp rate, we are unable to maintain, 3% also, but they have successful with 4% by successfully bypassing the water wall system. This is one of the most important point to be noted by the OEMs of the Indian power sector. They are able to bypass the radiation zone, where the 40 to 55% thermal energy transmits. They are able to bypass it, and automated combustion tuning and low load coal mills by implementing classifiers up to 100%, so that they can pulverize the coal much further, much finer rate, and dedicated condensate throttling. These are the important things Germany, Finland have implemented. The beauty of the Germany is every house is having a rooftop solar generator. So every consumer is a prosumer there. So that's how they are able to maintain. And China is also converted 250 gigawatts to the flexibilized units by upgrading technology with the retrofitting techniques like enriched burners, low load plasma igniters, dynamic mill operation, etc. So America is also has done the same thing. So here the point is, we have to learn from these experiences. We have to implement all these things. Here one more point, people are nowadays telling about the subcritical units, number 1 point. Second point, indirect firing. The Indian government has taken a decision to go with only supercritical from 2020 onwards. But since we are, reducing the load at the time of the peak solar generation up to 40%, and as the Benson point lies at exactly 40% of BMCR, which is 42% of MCR, that is TMCR, that is installed capacity, supercritical units are becoming subcritical at 40%. So what is the fun of having supercritical units? So it is better to go with the subcritical units of lower capacity with higher efficiencies, lower heat rates. So you take the case of Osaka generators. They are implementing 320 megawatts, 350 megawatts, I think, 2 into 350 megawatts, Osaka super thermal power station. We have to implement such type of technology is also. Our supercritical technologies are from 660 megawatts. We have to implement it with the lower capacity units also. That is one more point I wish to impress upon you here. And next, what are the required modifications? As I have discussed, these are advanced process control, enriched burners, and inching recirculation valve in the discharge of the BAP, and supervisory systems for stress of boiler turbine. A lot of metal temperature measurement TCs have to be installed. So such type of things we have to implement. Next, what happens because of this flexibilization measures if we take up in a unit? There will be two types of expenditures, CapEx and OpEx. CapEx, it may take to 20 to 50 crores per unit. Operational expenditure will happen because of increase in station heat rate and increase in O&M expenditure due to equipment deterioration because of the frequent low cycle constraints, and cost may enhance because of oil consumption. Oil consumption will increase because of two factors. Whenever the unit is at 40 or 45%, if any disturbance comes, unit will certainly trip. To avoid that one, the operator has to cut in the oil. This is first point. Second point, certainly number of unit trips will enhance when the load is being maintained at 40%. So because of these 2 points, the specific oil consumption will rise. So like this, as per a rough calculation, variable cost may rise by 25 paise per kilowatt because of increase in station heat rate, and because of O&M cost, it may increase by 10 paise per kilowatt. These two things are I have collected from some calculations. These two things are subject to correction. Yes. So next, how a unit performs if we flexibilize it to 55% and flexibilize to 40%. Turbine heat rate, if we go to 40% flexibilization, that is 40% of TML, it station heat rate increased by 10 to 14%. And auxiliary power consumption, as we already experiencing, it is raised by 10 to 11%. And these are some of other parameters. If you can see, boiler hydrodynamics will change, flame stability will lose, and boiler tube failures will increase. And as I have just explained, tariff will also increased by 20%. Life will be reduced by 10 years. If we continuously flexibilize the unit up to 40%, we are experiencing 2 to 3 times in a day, going back to 40% and going back to full load. Because in Telangana, our load curve, daily load curve will have 2 peaks, morning peak and evening peak. Among these 2 peaks, morning peak at 8 happens at 8 a.m., which is the peakest of these two because of the agricultural demand. So at that time, since the solar is not there, we have to maintain full load. And then at the midday, we have to come back to 40%. And evening, we have to raise to full load. And after 10, 11 p.m., we have to come back to the minimum load, 40 or 55% as per the demand. So like that, every thermal unit is facing almost 2 to 3 times of cycles, which certainly reduces the life 10 to 15 years, by 10 to 15 years. So apart from these stress on the thermal power plant, another new stress is because of global disruptions in the Middle East. Strait of Hormuz supply shock. LNG is going to reduce to India by 20% in the coming days. And what is the relation between this LNG and electricity? I'll explain. So these things will certainly ask the consumer to switch over to the electricity. This is what is called as deep electrification, as termed, defined by the Niti Aayog in their paper, Viksit Bharat Scenarios, Viksit Bharat and Net Zero. They have proposed deep electrification, especially in the 3 areas. That is, they have termed like this 3 pillars. Pillar A, transport, the mobility revolution. By 2035 or 2040, every vehicle should be electrical vehicle. So with that, a huge electricity demand, power demand will be there. Pillar B is industry. This is very hard to abate, but industry also has to come onto the electricity grid connected instead of diesel, petrol, or any other fossil fuels. And pillar C is digital infrastructure and buildings. Everything except 10 to 15% of form of energy should be transmitted to the electric power. So with that deep electrification, we may have to face very, very huge strain on the thermal power plant. Now, what is the way forward? We have to maintain the plant with the proper predictive maintenance. Even nowadays, we are maintaining the plant with the proper prediction, but AI-driven analytics is not yet available. The present requirement is huge digitalization, and AI-driven analytics should be implemented to predict boiler tube leakages, turbine fans, and pumps failures in advance so that it can be avoided. Next is combustion optimization, deep flexibilization, energy storage. This is one of the important point. By 2035, our installed capacity should be 3 times to that of present day capacity. So it should be almost 1300 gigawatts. In that 1300 gigawatts, we should have at least 20% of BESS, battery energy storage system, or PSP. Among these two, BESS and PSP practically Government of India CEA is telling 6 years, but as per practical experience, to commission the PSP from zero date means the point of time of having an idea of putting PSP to commission the PSP, it will certainly take 10 years, whereas BESS will take 12 to 14 months. So BESS is the immediate solution. To optimize these things, RE to the fossil fuel generation from morning to midday to evening to midnight, we have to keep these BESS, that is storage systems, in between these two, RE and fossil. That is what is called as energy transition. We have to transit to the battery immediately. That is the immediate requirement for India to install at least 80 to 100 gigawatts to accommodate the transition. So one more thing is the regulatory things. Regulation is available. CERC has come out with one this thing to compensate the amount to the thermal power generator, but that is not sufficient. So now the generators are approaching ERCs to compensate as per the actuals. So these things are to be taken care to take care of the thermal power generators.